What if I told you the biggest threat to the American auto industry isn't a lack of microchips, but a vault of Chinese engineering secrets so advanced they have practically been banned from U.S. soil? While Detroit is busy hyping minor tweaks to last year's models, Chinese automakers are quietly rolling out solid-state battery platforms and sodium-ion engines that completely rewrite the laws of physics. We are talking about cars that charge in the time it takes to order a coffee, platforms making traditional lithium-ion batteries look like ancient history, and tech that makes a $100,000 American EV. Today, we are cracking open the vault. I am going to show you the hidden, the restricted, and the downright unbelievable Chinese auto innovations that U.S. manufacturers are absolutely terrified you will see right now. Buckle up tight, because the automotive world as you currently know it is ending. To truly understand why American automotive executives are losing sleep right now, we have to start at the literal heart of the modern vehicle, the battery. For the last decade, the entire Western world has been trapped in a massive, trillion-dollar lithium bottleneck. Lithium is expensive, it is highly volatile, and refining it is a geopolitical nightmare. The United States government has spent billions of dollars and years of diplomatic capital trying to secure lithium supply chains just to build affordable electric vehicles. Entire supply chains were built around the assumption that lithium was the only way forward. But while the U.S. was desperately digging for lithium and cobalt, Chinese engineers did something that completely broke the global supply chain model. They bypassed lithium entirely. Welcome to the era of the sodium-ion battery. Chinese automakers like Jack Motors, backed by massive state and private investments, have already started mass-producing vehicles equipped with sodium-ion technology. Let's look at the Jack UAV. This isn't a concept rendering. It is a real car, delivered to real customers starting in early 2024. It utilizes a revolutionary honeycomb battery pack from Beijing-based Hina Battery. The groundbreaking part? It doesn't rely on lithium, cobalt, or nickel. Instead, it uses sodium, literally one of the most abundant, cheapest, and most widely available elements on the entire planet. You can extract it from the ocean. You can extract it from salt mines. It is practically infinite. But it is not just about being cheap. If you have ever driven an electric car in the freezing cold of a Midwest winter, you know the pain of watching your range gauge plummet. Cold weather destroys lithium-ion performance. Sodium-ion batteries, however, possess chemical superpowers that lithium can only dream of. They thrive in extreme temperatures. A sodium-ion pack maintains over 92% of its capacity, even in freezing environments down to -20 degrees Celsius. They are radically less prone to thermal runaway, meaning they are vastly safer, and will not spontaneously combust if the battery pack is punctured in a high-speed collision. Furthermore, they can take a rapid charge from 10% to 80% in under 20 minutes because the internal resistance of the cells is incredibly low. By completely eliminating the need for expensive rare earth metals, Chinese manufacturers are preparing to flood the global market with high-performance EVs that cost less than a used gas-powered sedan. We are talking about brand-new electric cars for under $10,000. The U.S. supply chain panic, the scramble for lithium mines in Nevada, the reliance on cobalt from the Congo, all of it was rendered completely irrelevant overnight by a battery made of salt. If sodium-ion is the solution for ultra-cheap mass-market cars, then what about the high-end luxury market? For years, American automotive startups and legacy brands in Detroit have been promising the world that solid-state batteries are the holy grail of EV. Solid-state means replacing the highly flammable, heavy liquid electrolyte inside the battery with a solid conductive material. The theoretical result is double the energy density, zero fire risk, and insane charging speeds. In the United States, solid-state is treated as a future concept, an engineering fantasy slated for maybe 2028, 2030, or beyond. In China, it is already rolling off the assembly line and into customer driveways. Take a look at the IML 6 Lightyear edition, a vehicle co-developed by SAIC and Qingdao Energy. This is not a concept car sitting on a spinning pedestal at the Geneva Auto Show. This is a production vehicle you can buy in China right now. It is equipped with a colossal 133 kilowatt-hour semi-solid-state battery. Because the solid-state architecture allows them to pack radically more energy into a much smaller physical space, the car doesn't weigh 1,000,000 pounds like the GMC Hummer EV. The result of this efficiency? A verified mind-bending cruising range of over 1,000 kilometers on a single charge based on the CLTC cycle. That is over 620 miles. You could drive from New York City to Detroit, Michigan, and still have battery left to drive around the city, all without plugging in a single time. And when you do finally need to plug in, the IML6 utilizes a quasi-900-volt ultra-fast charging architecture. In exactly 12 minutes, you can add 400 kilometers of range to the car. 12 minutes. That is how long it takes to walk into a gas station, buy a coffee, and use the restroom. Then there is the Neo ET9, an ultra-luxury sedan utilizing a 150 kilowatt-hour semi-solid-state pack developed by Lion. NIO didn't just claim their battery was revolutionary in a press release. To prove it to the world, their CEO, William Li, literally live-streamed himself driving the car for 14 hours straight, covering 1,044 kilometers on a single charge during a brutal winter road trip. Western legacy automakers are terrified because they are still dumping billions into figuring out how to squeeze 300 miles out of a heavy, liquid-based lithium pack. Meanwhile, Chinese solid-state technology is completely erasing the concept of range anxiety from existence. They have solved the power equation at both ends of the economic spectrum: dirt cheap sodium for the masses, and ultra-dense solid-state for the luxury market. But endless batteries mean absolutely nothing if the car itself drives like a brick. Power is completely useless without control. And that brings us to the technology that literally makes American suspension systems look broken. Prepare yourself, because we are moving from the power source to the gravity-defying chassis. When you think of a car suspension, you probably think of metal coil springs and fluid-filled shock absorbers designed to passively absorb bumps. The United States has had magnetic ride control for years, and it is great for smoothing out a bumpy road. But Chinese engineering has taken the concept of the suspension and turned it into an active, intelligent robotic limb. Enter the BYD DSUS Intelligent Body Control System. This is not just a suspension. It is a full vehicle hydraulic and pneumatic control network that calculates and adjusts the car's height, stiffness, and balance thousands of times per second. During a live demonstration that left automotive journalists absolutely speechless, BYD drove a multi-ton electric supercar, the Yangwang U9, onto a stage, completely removed the front right wheel, and then drove it around the track perfectly level. The DSUS system was calculating the exact hydraulic pressure needed to keep the car balanced on three wheels, actively compensating for the missing corner in real time. Think about the safety implications of that. If you suffer a high-speed blowout on the highway in a standard car, you are likely going into a catastrophic spin or a rollover. In a vehicle equipped with this level of intelligent chassis control, the car will instantly stabilize itself, dynamically shifting the center of gravity and allowing you to safely pull over to a complete stop. But it gets crazier. The DSUS system is so incredibly powerful that it can literally launch the entire car off the ground from a standstill. It can jump. And BYD isn't alone in this chassis arms race. Let's look back at the Neo ET9 luxury sedan. NIO equipped this vehicle with an active, independent hydraulic suspension system driven by dedicated microprocessors at each individual wheel. To demonstrate its capability, NIO parked the ET9 outside in a freezing blizzard. When the vehicle was covered in a thick, heavy layer of snow, the car activated its chassis system and literally shook itself back and forth, vibrating with such precise frequency and force that it shook all the snow off its roof, hood, and windows, exactly like a wet dog drying itself off. Try doing that with a standard American luxury sedan. You can't. The mechanical capability simply does not exist in Western production vehicles. Then there is the BYD Yangwang U8. This is the vehicle that keeps Detroit executives awake in cold sweats. It is a massive, luxurious, quad-motor electric SUV that produces nearly 1,200 horsepower. It looks like a vehicle built for a Bond villain. But its party tricks are what make it feel like alien technology. Because it has an independent electric motor powering each individual wheel, the Yangwang U8 can perform a true tank turn. By spinning the left wheels forward and the right wheels backward at the exact same speed, this 7,000-pound behemoth can rotate 360 degrees in place, perfectly pivoting on its own axis. But the true shocker is what happens when you drive this luxury SUV into a lake. The Yangwang U8 features an IP68 rated waterproof architecture and an emergency floating mode. If you are caught in a severe flash flood or accidentally drive into water deeper than 4 meters, the vehicle's onboard sensors instantly detect the danger. Within milliseconds, the car shuts down its combustion range extender engine to prevent water intake, seals all the windows tight, switches the air conditioning to internal circulation to save your oxygen, and automatically opens the panoramic sunroof to provide an emergency escape hatch. Then the DSUS suspension raises the vehicle to its absolute maximum ride height, and the car literally becomes a boat. It will float completely buoyant on the surface of the water for up to 30 minutes. And it doesn't just drift helplessly. By utilizing the independent wheel motors to paddle the water like riverboat wheels, it can navigate at 3 kilometers per hour back to dry land. It is a luxury SUV that transforms into an amphibious rescue vehicle without the driver pushing a single button. So, they have the infinite power, and they have the indestructible amphibious hardware. But what happens when you give these mechanical beasts a mind of their own? Hardware is one thing, but the software running these machines is exactly why the United States government is stepping in to shut them down. Welcome to the autonomous overreach. In the United States, the race for autonomous driving has largely been defined by cameras. Legacy automakers and massive USF companies have heavily leaned into vision-only systems. Their argument is simple: if humans can drive using just 2 eyes, cars should be able to drive using just cameras. The problem with cameras is that they suffer from the same limitations as human eyes. They can be blinded by harsh sunlight, they struggle to see in heavy rain or snow, and they have to guess distances based on flat pixel data. Chinese automakers took a completely different, much more expensive route: LiDAR, light detection, and ranging. LiDAR shoots millions of invisible laser beams out from the car every single second, bouncing off objects and returning to the sensor, mapping the entire world in highly accurate, three-dimensional, military-grade topographical detail. For years, LiDAR units were massive, spinning buckets on the roofs of test cars that cost up to $75,000 each. American companies deemed them way too expensive for consumer vehicles and largely abandoned them. But Chinese tech giants like Hesai and RoboSense did what China does best. They miniaturized the technology and mass-produced it at an unprecedented scale. Today, almost every single premium Chinese EV comes equipped with sleek, roof-mounted solid-state LiDAR units that cost just a few $100s to manufacture. Vehicles equipped with Huawei's ODS 3.0 autonomous driving system don't just see the road. They map it with millimeter precision in real time. It doesn't matter if it is pitch-black darkness, dense fog, or a blinding blizzard, the LiDAR sees perfectly. They process this massive stream of 3D data through proprietary neural networks that are learning and evolving with every mile driven by the fleet. This isn't just advanced cruise control. These cars are gathering terabytes of high-fidelity environmental data every single day. They know exactly where every building, every stoplight, and every pedestrian is in real time. And that raw data feeds into the next terrifying leap, the smart cockpit. In the West, integrating your phone with your car usually means plugging in a USB cable and waiting for Apple CarPlay or Android Auto to boot up so you can mirror your maps and Spotify. It is a clunky third-party bandage slapped onto outdated legacy automotive software. In China, consumer electronics giants have entirely taken over automotive software. Take the Xiaomi SU7, a highly anticipated electric sedan built by one of the world's largest smartphone manufacturers. The car runs on Xiaomi's HyperOS, the exact same operating system that runs their smartphones, their smartwatches, and their smart home appliances. When you step into a Xiaomi car, there is no Bluetooth pairing process. The car instantly recognizes your phone on a hardware level. Your active phone calls, your navigation, and your media instantly teleport to the car's massive central screen without a single tap. Because the car is part of the exact same digital ecosystem as your house, you can use the car's voice assistant to turn on your living room lights, adjust your home thermostat, and check your security cameras while driving 80 miles an hour down the highway. The car's interior even features magnetic pin connectors around the dashboard, allowing you to physically snap on tactile buttons, extra screens, or smart accessories that instantly integrate with the car's central brain. The vehicle knows your daily schedule. It knows your exact location mapped by military-grade LiDAR. It knows your biometric data from the steering wheel sensors, and it is constantly connected to a massive cloud network. The car is no longer just a vehicle designed to get you from point A to point B. It is the most powerful, mobile, data-gathering supercomputer you own. This level of technology, the 1,000-kilometer solid-state batteries, the amphibious suspensions, the military-grade LiDAR, and the hyper-connected software ecosystems should cost a fortune. It should completely bankrupt the companies attempting to build it. So how are they selling these absolute marvels of engineering for less than a stripped-down base-model American commuter car? The answer lies in a manufacturing cheat code that caught the West completely off guard. For over 100 years, building a car meant taking hundreds of individual stamped pieces of sheet metal and having robots or humans weld them together. It was a slow, incredibly expensive process that required massive factory footprints and thousands of workers. American companies started pioneering a concept called Gigacasting, using massive die-casting machines to inject molten aluminum into a single mold, creating the entire front or rear subframe of a car in one solid piece. It was brilliant, but Chinese manufacturers didn't just copy the concept. They scaled it to a level of industrial aggression the world has never seen. Chinese automakers are currently using ultra-massive 9,000-ton and even 12,000-ton die-casting machines. They are consolidating hundreds of manufacturing steps and dozens of parts into a single 60-second press cycle. But gigacasting is only half the story. The real manufacturing cheat code is total, ruthless vertical integration. When a Western automaker designs a car, they are largely an assembly company. They buy the brakes from Bosch, the seats from Lear, the batteries from Panasonic or LG, and the software from Google. Every single middleman takes a profit cut, driving up the final price of the vehicle. Companies like BYD do not buy parts. They build the batteries themselves. They build the electric motors themselves. They build their own microchips. They build their own seats, their own dashboards, and their own wiring harnesses. BYD even bought their own massive roll-on, roll-off cargo ships to export the cars themselves, cutting out maritime shipping companies entirely. By owning the entire supply chain from the raw lithium and sodium mines all the way to the shipping logistics, they have slashed the cost of vehicle production to a level that makes competing on price mathematically impossible for Western brands. And that brings us back to the high-stakes geopolitical war we started with at the beginning of this video. How is the United States responding to this overwhelming wave of superior, radically cheaper technology? They are pulling the emergency brake on the entire industry, realizing that domestic automakers could be financially wiped out in a matter of months if these vehicles flooded the U.S. market. The U.S. government took unprecedented, aggressive action. They didn't just raise taxes. They implemented a staggering 100% tariff on all electric vehicles imported from China. If a Chinese automaker builds a revolutionary $30,000 EV, it will instantly cost $60,000 the second it touches American soil. The goal is to artificially price them out of the market to protect Detroit's legacy automakers. But the fear goes much, much deeper than just economics. It is about national security. Remember that advanced LiDAR and smart cockpit software we just talked about? The U.S. Department of Commerce recognized that having millions of hyper-connected, LiDAR-equipped vehicles roaming American streets constitutes a massive, uncontrollable intelligence vulnerability. They officially proposed a sweeping, historic ban on the import and sale of any connected vehicles containing software or hardware linked to China. They aren't just banning the cars. They are banning the digital nervous systems that make them so advanced. The proposed rule targets software and hardware, effectively building an impenetrable digital fortress around the American auto industry. The message is clear: if the car can talk to a Chinese server, it is not allowed on American roads. Behind this legislative fortress, us automakers are scrambling in a state of sheer panic. Knowing they cannot rely on government protectionism forever, American aerospace and automotive engineers are frantically pooling resources to develop next-generation engines and propulsion systems for 2025 and 2026. They are heavily investing in hydrogen fuel cells, advanced hybrid systems, and radical improvements to their own battery densities to try and close the gap. The American response isn't to surrender. It is to buy enough time to leapfrog the technology entirely. The global standard for what a car is supposed to be has permanently changed. Whether these exact vehicles ever make it to your local dealership or remain heavily restricted by government bans and 100% tariffs, the Pandora's box of automotive innovation has been opened. The 1,000-mile solid-state batteries, the amphibious suspensions, the autonomous LiDAR mapping, they exist right now. They are being driven by real people today. The race for the future of transportation is no longer about who can build the best car. It is about who can control the technology that runs the world. Detroit has been given a lifeline, a few extra years behind a wall of tariffs to catch up. But the clock is ticking, and the competition isn't just in the rearview mirror anymore. They are already at the finish line. Thanks for watching. If you want to stay ahead of the curve and uncover the engineering secrets the mainstream industry doesn't want you to know, make sure to hit that subscribe button. We will see you in the next one.